So in this video, we are going to study potential energy of a system of charges. Let us consider firstly 2-point charges Q1 and Q2 separated by a system of some distance R1. So in this lesson, we are going to calculate the potential energy of this particular system. So the potential energy of this system is nothing but work done in making this system itself. So potential energy of the system of charges is the work done in making this configuration itself. Meaning, the total potential energy of this system is the work done required to make or build this system itself. So what is your system here? Our system is a system of two charges. So when we make this particular system, and what is the the net work done in making this system itself is the potential energy of the system of these two charges. So let us make or build this system and find what is the total work done in making this system, and that will give me the potential energy of the system. So firstly, what I do here is, suppose I have some charges Q1, Q2 out here at infinity. So I will bring them in their respective positions like this and find the total work done in placing them in their respective positions, and I'll calculate the work in that particular case. So firstly, I'll bring charge Q1 to this position. Suppose this position is E and this position is B. So I'll bring Q1 charge to position A. So if I bring charge Q1 to position A, what is my work done in bringing this charge Q1 to position A? Definitely, you have brought this charge as Q1 at position A, where there were no charge around this particular position A. This Q1 was the only charge to be bring on the position A. That means work done 1 is 0. So if you bring a charge Q1 in an open space, then your work done in such cases will be 0. Now if you bring charge Q2 at position B, so you have a position B and you are bringing charge Q2 at this position, which is at a distance of R1 from position A. Then now if you bring charge Q2 to this position, then you need to do some work in this case, because this charge Q2 is influenced by this charge Q1, because this Q1 charge will affect this Q2 charge to come at this point, or this charge Q1 will push this charge Q2 away as much as you wants to bring it closer to Q1. That means you need to do work against the reaction of this charge Q1 on bringing charge Q to this particular position B. That means, so work done in bringing charge Q2 to this position B will be, we already have work done in bringing an unit charge from infinity to any position is nothing but work done in bringing unit positive charge from infinity to any point was nothing but it was our definition of electrostatic potential itself. It was 1 by 4 pi epsilon naught. you are bringing a unit positive charge around any charge q, then you have to do this much amount of work, and that work itself is the electrostatic potential around this charge q. So in that case you're bringing 1 unit positive charge, but in this case you are bringing q2 amount of charge. So the work done in bringing q2 charge around this q1 charge, which is at a distance of r1 from q2, will be 1 by 4 pi epsilon 0 q1 q2 divided by r1. So this is our work done 2. So total work done will be, work done in this case will be W1 plus W2. That means work done will be 0 plus this will give me just the second value only. So this is the total work done in bringing charge q1 and q2 to their respective position, or this is the total work done in making the system as a whole. And this work done is nothing but it is the potential energy of the system itself. So potential energy of the system is, potential energy of this system is nothing but it is 1 by 4 pi epsilon naught q1 q2 by r1. So this is the potential energy of the system. Suppose we have a three charge system. Suppose we have a 3 charge system like q1, q2, and q3. Let r12 be the distance between q1 and q2, r23 be the distance between 2 and 3, and r13 be the distance between q1 and q3. So what is the potential energy of such system? What will be the potential energy of this system? So the potential energy of the system is the total work done in making this system as a whole. So let us try to make this system firstly. So you have 3 charges at infinity initially. So you brought q1 charge to this position, very position A. You are bringing this charge q1 to position A. That means what is the work done in bringing q1 to position A? So work done 1 will be 0, because in bringing q1 charge to position A, there is no any other charge initially around this charge q1. So you will bring this charge q1 at point A without any effort or without any influence of any other charges. So your work done 1 is 0. Now when you bring this charge q2 at position B, now what you have to do is, now you are influenced by this charge q1, because you are bringing this charge q2 in the presence of this charge q1. That means you have to do some work against the force of repulsion of this charge q1. So work done in bringing charge at point q2 will be influenced by this charge q1. So W2 will be our 1 by 4 pi epsilon naught q1 q2 divided by r12. So this is our W2. Similarly, now you bring W3 to this position q3. W3 is the work done in bringing this charge q3 to position C. Now when you bring this charge q3 to C position, now there were 2 charges initially at this positions. q1 and q2 were already there, so you are bringing this charge q3 in the presence of q1 and q2. That means the work done by this work done in taking this charge q3 to position C will be influenced by the repulsive force of q1 as well as the repulsive force of q2, or it is influenced by the presence of 2 charges q1 and q2. So W3 will be your 1 by 4 pi epsilon 0. Firstly, it is influenced by this charge q1, so q1 q3 divided by the distance between them r13 plus 1 by 4 pi epsilon 0. Now it is also influenced by q2, so q2 q3 r23. So this is our W3. So network done is W1 plus W2 plus W3, that is 1 by first W1 is 0 plus 1 by 4 pi epsilon 0 Q1 Q2 divided by R12, this one, plus 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 divided by R23. So this is the total work done. Now this total work done is nothing but it is the potential energy of this system itself. So this is the total work done in making this configuration, which is the potential energy of the system itself. So potential energy of the system will be energy of the system of charges, system of 3 charges, will be in this case U is equals to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 plus 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 divided by R23. So take common, 1 by 4 pi epsilon naught comes outside, so Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus 1 by 4, okay, it is taken common, Q2 Q3 divided by R23. So this is the total potential energy of the system. So your homework will be find the potential energy of system of find the potential energy of system of n charges. So that this is you're going to do at your home. So this is it for today. Thank you.